Hello everyone, a very warm welcome to everyone in today's section of thyroid adenomas. Here we go through the introduction, pathogenesis, clinical features, diagnosis, as well as treatment of the thyroid adenomas. So let's begin through the introduction. First, we see the thyroid follicle of the thyroid gland. Here we can see this is the thyroid follicle, which has been surrounded by the follicular cells, and in the center there is colloid. And these thyroid adenomas are the solitary mass or discrete mass that is derived from these follicular cells or the follicular epithelium that is surrounding the follicle. And since it is derived from this follicular epithelium, so thyroid adenoma is also called as follicular adenoma. And this thyroid adenoma can be functional or non-functional depending upon whether they are producing or they are acted upon by the thyroid hormone or not. So if they can produce the thyroid hormone, then they are called functional. But if they can't, then that are called as non-functional thyroid adenoma or follicular adenoma. And majority of adenoma are non-functional. Very few are functional. And those which are functional, they can produce thyroid hormone, and that is independent of the stimulation by the thyroid stimulating hormone. So this kind of functional thyroid adenoma is also known as toxic adenoma. Next, we see the pathogenesis of the thyroid adenomas. Here we see there is a somatic mutations in the thyroid stimulating hormone signaling pathway. Various genes which are involved in this signaling pathway are undergone mutation due to certain reasons, and there is a two-hit model and a EZH1 function hypothesis in this thyroid adenoma, which state that first hit is activating mutation in the TSH receptor gene or the GNAS gene that lead to the constitutive activation of the CMP protein kinase A pathway, and that results in increased thyroid hormone secretion in the cell proliferation. And next, in the second hit, there is EZH1 mutation, which is the second genetic event, and that cooperate with this TSH receptor or GNAS mutation to further promote the growth of the thyroid cells. Such things can be seen in two-hit model of this thyroid adenoma. Here we see this GNAS gene encode alpha subunit of the stimulatory Z protein, and once there is a somatic mutation, activating somatic mutation in this GS alpha protein coding GNAS gene, then that results in the lagging of hydrolysis of the GTP that is bound to the alpha subunit. So this results in sustained activation of adenyl cyclase, leading to increased level of the CMP. And this elevated CMP then triggers the intracellular signaling pathway to promote the cell hyperfunctions and proliferation. And this mutation in the GNAS gene leads to the persistent activation of the CMP pathway, and this even happen without TSH stimulation. So this results in excessive thyroid hormone production and uncontrolled cell proliferation within the thyroid, and this lead to the formation of autonomous thyroid nodules and adenomas. So EZH1 gain of function mutation. What EZH1 gene encodes? This encodes for histone methyl transferase, which is essential for the methylation at lysine 27 and the histone S3. And this is a crucial epigenetic modification that is required for various gene regulation and also for the chromatin structure regulation. And if there is gain of function mutation in this EZH1 gene, that then enhance the proliferation of the normal thyroid cells and further promote the adenoma when it is present with the activating TSHR gene mutation. And this mutation lead to increased level of this um, histone 3 lysine 27 methyl transferase, which is the marker of heterochromatin. And this results in more compact chromatin structure and promote cell proliferation. Now, in functional follicular adenomas, there is a TSHR gene, and EZH1 gene mutation, and such alterations in follicular carcinoma are very rare to be found. So these toxic adenomas are these functional follicular adenomas do not seem to be precancerous lesions since they are not going to cause or they are not going to be so malignant that can develop to follicular carcinoma. But in case of non-function, about 20 to 40% there is mutation of the RAS gene, and about 5 to 10% there will be mutation in PPAR gamma mutation. There is the translocation and the formation of the fusion protein. So such types of gene alteration are very commonly present in follicular carcinoma. So these non-functional follicular adenomas can be called as a precursor to the follicular carcinomas. But in case of functional follicular adenomas, that is very rare to be malignant. Now we see the morphology of follicular adenoma. First we go to the gross. Here we can see there is a patchy hemorrhage and the encapsulated and intact capsule. There is no capsular invasion in adenomas. And um, there is a solitary spherical encapsulated lesions that is demarcated by a well-defined and intact capsule, and the color ranges from gray white to red brown depending on the cellularity of the adenoma and its colloid contact. And if there is larger lesions in the affected region, then there can be seen the areas of hemorrhage, fibrosis, calcification, and the cystic changes. So in such things can be appreciated. Next we see the microscopic feature of this follicular adenoma. Here we can appreciate the area of hemorrhage and the intact fibrous capsule, and these are the normal thyroid parenchyma, and in the follicular adenoma there is well circumscribed encapsulated nodule, and that compresses the adjacent thyroid parenchyma. Like these yeah, encapsulated thyroid adenoma compresses these unaffected areas of the thyroid parenchyma. Here we can see there is a little variation in the cell size, shape, or nuclear morphology and mitotic but that are not so significant. And neoplastic cells acquire brightly eosinophilic granular cytoplasm, that is oxophil or Hurthle cell changes. Such things can be seen. Now the clinical features that we can appreciate in follicular adenomas are solitary painless masses that can be discovered on the routine physical examination of the neck, and that may produce local symptoms such as difficulty in swallowing. And diagnosis is done mainly by the radioactive iodine scan. These are thyroid adenomas. The nodules in these adenomas can uptake the radioactive iodine, and that results in the appearance of the hot nodules and creating the hot spot. And this happen in the functional adenomas, while in non-functional adenoma the nodules cannot uptake the radioactive iodine, so that are present as cold nodules. And we already discussed about that non-functional adenomas are precursors to the follicular carcinoma, and Cold nodules can also be appreciated in follicular carcinoma, which we see in the follicular carcinoma, in the video of the follicular carcinoma. Next, we see the difference in this follicular adenoma and the follicular carcinoma, and this difference is found by the fine needle aspiration biopsy, where the cells are aspirated from the biopsy and from the fine needle, and evaluation of the capsular integrity is done for the diagnosis of the adenomas, and we see the capsular integrity is well maintained in case of the adenomas. That is, the capsule in adenoma is not as thick as it is in follicular carcinoma. That means capsular invasion can be appreciated in follicular carcinoma, which is rare to be found in the follicular adenoma. Such things can be appreciated from the biopsed sample. It's much for now. Thank you for having